Hello, this is Mr. Stansbury. I'm going to take you through the notes on proving and applying congruence rules. At the end of this, you should be able to say, I can prove that congruence criteria follow from the definition of congruence, and I can use the congruence criteria in simple proofs. Okay, so first things first here. We've got, here's how we want to go about writing triangle congruence proofs. Okay, all three congruence statements must be written in the proof, even if it seems obvious. Okay, so for example, if you're using SAS for side angle side, you need two side congruency statements, and one angle congruency statement. Okay, now, very important, you cannot assume anything. It's only true if it's given, marked, or if it's a definition. If something looks like it's congruent, but it's not given or marked, you cannot assume that it's congruent. Okay, so that's very important. Steps that you want to follow. First thing you want to do, mark what you know. That's the given information, possible shared sides, and possible vertical angles. Those are the three biggest ones that you want to pay attention to. Second thing you want to do is figure out which congruence criteria you're going to use: angle, side angle, side angle side, side side side, side angle angle, or hypotenuse leg. Okay, and then the third thing is to complete the proof. All right, so let's take a look. All right, so here's example one here, just a proof that we have. Given LO is congruent to MN. First thing I would do if I were you is, like, right off the bat, as soon as we get the given pieces, let's mark it up on our diagram so we know what's going on. So LO, this here, is congruent to MN. So these two pieces are congruent because it tells us. Next thing, angle LOM is congruent to angle NMO. So LOM, this angle here, is congruent to angle NMO. Congruent to that there. Okay, now we got to prove that LMO, triangle LMO, is congruent to NOM. Okay, so let's do this. First thing we want to do, let's start off with our given pieces. So we know that LO, segment LO, is congruent to segment MN. How do we know that? That is given. Okay. By the way, I'm going to show you a couple different ways of proof. This is just a two-column proof, and then this is a little bit different look at the proof here. Okay, so LO is congruent to MN. LO is congruent to MN. And the congruence criteria on that is a side. Okay. So that's one of our given pieces. So let's pause for a second here and figure out what we're going to end up do. Like on this proof model here, you want to figure out what you're going to use for your congruency at the beginning. So let's figure that out. So we have a side and we have an angle. Now we know right here that this MO is going to be congruent to itself, right? Because it's this MO is part of both of the different triangles, so MO has to be congruent to itself, right? So that one's congruent. So we're going to end up having side, angle, side. Okay, so what we want to do with this is you want to do side, angle, side in order for this type of proof here. Okay, so we've got one side, LO congruent to MN. We want to come up with the angle. We know that these angles are congruent because they gave that to us as well. So angle LOM is congruent to angle NMO because that was also given. Okay, so that's our side angle. And then our last side, we know that MO is congruent. Ooh, that's a bad one. Congruent to MO. And that is, one thing is congruent to itself. And if you'll remember, that is the reflexive property. Okay. So that's all there is for this one here. We have to prove that we have a side angle and side angle and side congruent to the other side angle and side. And we have now shown that these two things here, triangle LMO is congruent to triangle NOM. Okay? All right, before taking a look at the other way of the two-column proof, let's have a little comedy break.
The juice aisle, and that is, I don't know what's going on with cranberries, but they're getting in all the other juices. Whoever the salesman is for cranberries does a great job. He's showing up everywhere. Hey, what do you got, apples? Put some cranberries in them. We'll call it cran apple, go 50-50. What do you got, grapes? How about cran grape? What do you got, mangoes? Cran mango. What do you got, pork chops? Cran chops. Why don't you back off, cran man? Why don't you take your sales trophy and have a vacation? He's working too hard. He's making the other fruit guys feel bad, you know? Like the banana guy wakes up, man, I ain't into nothing. Cram man's all coupled up. You gotta get cracking, banana man. You gotta get on a stick.
All right. So, okay, so two-column proof. First thing, statement. We know that LO is congruent to segment MN. And how do we know that? That is given. Okay, we also know that angle LOM is congruent to angle NMO. Oops. NMO, also given. We figured out that MO is congruent to MO. MO congruent to MO. And that is because of reflexive property. Okay. And then our last statement is our congruence criteria. Well, it's not the statement, but our last piece is always our prove statement, right? So prove. So we know that triangle LMO is congruent to triangle NOM. Why do we know that? Because of side, angle, side. Okay? So, two different types of proofs to prove the same thing. Let's take a look at one more proof, and we'll call it good. Okay? I'm just going to do just a two-column proof on this one. So, first thing, given, we know that angle V is congruent to angle X. Okay? So, V, this here, is congruent to angle X there. Why do we know that? Given. We also know that VW is congruent to XY. Okay. Those are segments. Also given. Now, let's see. Let's mark that up. We got VW. So this is congruent to this. VW is congruent to XY. Now we need one more thing. So hopefully you're noticing in here, these are vertical angles. So we know that this angle here has to be congruent to that angle there. So let's call that angle XZY. So angle XZY is congruent to angle VZW. VZW. And how do we know that? That is vertical angles. Okay. And then, so now the last thing is hopefully these are congruent to each other. And it's going to work because we have angle, angle. So we have the two. Here's how I like to try this out. So we have the angle. Like figure out whatever you have. If it's angle, angle, side, or side, angle, side, or something like that. Whatever you have two of, I'm going to write those in there. And I'm going to leave a little space in between and see how this works. So here's what I'm going to do. So I look at the two angles. And if the side is in between those two angles, I'm going to write angle, side, angle. Since the side is not between those, it's going to be out here. It's angle, angle, side is going to be our congruency statement there. Okay, so just to make it look a little nicer, let's move that A over. And we know that, oops, our triangle VWZ is congruent to triangle XZY. Okay? All right, that's all there is for proving and applying congruence rules. If you have any further questions on this, please feel free to ask in class. Thanks.